Welcome back to the Build Your Own AI video series. In this video we are going to continue developing the chatbot capabilities. In the last video I mentioned I was planning a model where simple statements with a known intent and response could be handled by a chatbot mechanism that I previously designed. But when statements with an unclear intent were received, we would leverage a more generalized machine learning model. I was going to build the machine learning model based on an example Suraj Raval had posted on YouTube. However, I've since found that the methods used in that video are no longer supported in the latest versions of TensorFlow. I guess that's a measure of how fast things are moving in the world of machine learning, but it has set me back a little bit in terms of my AI development, as I will now need to research this aspect further. But that has not stopped me from incorporating my previous code into this new AI framework. The mechanism we will build in this video will work as follows. Some trigger on the client will request chat text from the brain. The Python voice logic on the brain will look up the requested chat text in a table in MySQL, with some randomness allowing for varying responses. The requested chat text will then be returned to the client, where the Python voice logic will call Pico to Wave to speak the text. The Pico to Wave logic was created in our previous video. The user may be asked a question, and the response may then trigger another request of chat text, to which the brain will respond accordingly, and so on. The trigger for the initial request of chat text might be the fact that we detected motion, or that a spoken request was mapped to a certain chat thread. We are initially going to focus on the motion detection scenario, as that is where we left off in the last video. Here is a section of code from the client motion file that handles actions related to motion detection. Firstly, note that we fetch the variables from our environment dictionary, as these indicate how we should respond to motion. Then we check whether a person was detected by the brain when motion was sensed. And finally, if a person was detected, we now fetch the appropriate chat thread based on our current environment settings. This will trigger a request to the brain, and when the robot brain receives the message via the message queue, our callback function has now been extended to call a new module on the brain side to process voice-related sensor inputs. Let's take a look at that new module, brain_voice.py. When our brain receives a request from the client, it will execute the do logic function, which will firstly check the content type received. I have a placeholder here for later when our client will be sending voice commands, but let's focus right now on the JSON-based requests. If the JSON is a request for chat content, we will call the getChat function, which then recursively fetches our Lego-like conversation blocks from the database, with a little randomness thrown in so that they seem more natural. Then it's bundled up and sent back to the client, where it'll be processed with the logic on the client side. Our client voice code now also has a do logic function, which can be called when a message is received from the brain with an app ID of voice. This checks the JSON for the action type, and if chat is required, it runs the new do chat function. This function recursively loops through the JSON received and uses our say function from the previous video to speak the text. Additional functions can be triggered via the JSON return from the brain, such as asking for user input. The only one we have so far is to get a yes or no response, but based on that response, we can then fetch more content from the chat database. So let's once again run a quick test of our bot logic, where we should be able to now trigger our speak commands or our voice commands using motion.
Hello, how are you today? I am feeling very good today. Would you like to hear a joke? Sorry, I did not hear yes or no. Would you like to hear a joke?
Okay, so another successful test, but as you can see we have no way of responding to the questions. Our AI can speak, but not listen. In the client_voice.py, I've already inserted a reference to a client STT file. This file will hold our listening and speech-to-text functions. You can see I've already added a placeholder here, but it's just returning a fixed field text value of whatever. So let's make our AI a better listener. Firstly, you'll need to install PyAudio using this command. Then we'll add these imports at the top of our client STT file, and then replace our listen function with the following code. This will record 10 seconds of speech or stop when relative silence is heard. I say relative silence because we need to know average background noise levels to determine if sound is returned to that level. I'm going to use our hot word detector to constantly calculate background noise levels, but we've not yet built that, so Let's put in a placeholder for the moment just to fix that noise threshold parameter. Then, after recording sound, our sound file is sent to a speech-to-text engine using a function named transcribe. I have not yet found a decent speech-to-text engine that runs locally. If you have, then please tell me in the comments. So I'm going to use Google. The Google API gives you 60 minutes of free usage per month. So even if our recording is the full 10 seconds long, you are still going to get more than 10 free commands every day. And once we shorten our recordings with detection of silence, it'll be much more. You will firstly need to create an account to use Google's APIs. Then, create a project in the Cloud Console and enable the speech-to-text API for that project. Ensure the project is selected in the top menu bar. Then select I am an admin from the menu, create a service account, and finally create a key for that service account. To leverage the Google Speech-to-Text API in Python, you'll need to run these commands to install the necessary libraries. Note that I was planning on running the speech-to-text operations on the brain, but it seems an unnecessary complication to route this operation through the message queue when the client could do it easily. Now, in the client STT file, I've added the necessary imports at the top of the file. This JSON-based key that you downloaded from Google allows Python to authenticate to Google Cloud. The JSON file must be stored in a subfolder under the root folder where our Python code is stored, and the name of the file as well as the Google application name must be set here. Finally, I've added a new translate function to convert our recorded speech to text. Let's now give things a test.
Hello, how are you today?
I'm good, thanks. How are you?
I am feeling happy. I like being a robot. Would you like to hear a joke?
Yes, please. Tell me a joke. I would like to hear a joke.
What is easy to get into but hard to get out of?
I don't know. You tell me.
Trouble. Ha ha ha. I like that one. Would you like to hear another?
No, I would not like to hear another joke. Thank you.
Okay, let me know if you need anything else.
Okay, so I think that was a pretty successful test. So if you're having some trouble, what I'd recommend is you first test that your default microphone is going to record your voice using this command here, and these notes are on GitHub. And then you can test that the default output device is going to play that recording or any other WAV file using this command here. If either of those are not working to record or play, then you've got some problems that you need to debug with your default devices on your PC or your Raspberry Pi. And one final note here, if you wanted to test the Google setup by itself without all of the other complexity, you can run this client STT file by itself. Just ensure that you have the path here to your the location where you are storing the default files, because that path combined with the details up here needs to find its way to that Google key file so that it can actually authenticate into the Google APIs. Once you have that set, you can run this in isolation to test your Google API setup. So thank you very much for watching. In the next video, we're going to set up the hot word detector, so we're able to actually use speech to command our bot. And once again, thank you for watching. Hit subscribe if you want to be notified when the next video is available. Thank you.